degrees is pure red. Then it goes 120 degrees is pure green, 240 degrees is blue, and then red again. This is important because it is related to the way that our eyes and our brain perceive colors. I give him 100% saturation. It is completely red. And in the lightness, I wrote -50. This is related also to the way that Photoshop uses color. And it uses color in the lab domain of colors. Lab domain is very similar to the way that we perceive colors in the real world. It's strictly correlated to our brain, to the stimulus that comes from the light from outside that comes in our eyes, and the brain processes it for giving us the impression of colors. Because colors are not properties of the objects. They are just interpretation that we give to different wavelength energy that comes from a light source. But they're not physical property of an object. That's important to understand, because the majority of living beings are not trichromats, so they don't see colors at all. They just need to see the light. We are very few animals that see colors. Okay, now I see this level colorize all the 3 levels downside, but I wanted this one to colorize just the red, not the all 3. How can I do that? I can go here, layer, and okay, layer, create clipping mask. So you go here, layer, create clipping mask. Sorry, it doesn't get the command. No, release. Okay, you see here, this one is here, and then it goes on the right with a small more arrow. It says now this one is related just to this. If I remove the eye that show me the layer, I don't see red at all. The shortcut for doing this is holding the Alt key here. You see the cursor is changing. You just do this and you have a clipping mask. Okay? Now this is my red channel. I duplicate it and I put it here on the green. The only thing I have to do now is to tell the program this one is green. So I changed the hue to 120. It's green, pure green, as we said before. You can see it there, it's pure green. And I do the same. So I want this to colorize just the down level. I copy and I do the same for the blue. 240 is pure blue. Okay, now I have my 3 color channel. I still see just the red one because the red doesn't let the light from the beneath levels to pass through. I go and change the layer to screen mode, and I'm starting to colorize because it acts just the red are zoomed on the green. I do the same for the green. Okay, and I have my color image. This seems to be complicated, but you can always change stuff. I can change the hue of the channel. I can change the saturation. So I have much more control all over the image. I can also add level adjustments on the top of it. Okay, so I can adjust the level just for the blue channel, for example. But anyway, I get my tricolor, so now I can flatten my image, and I have my RGB image. Another stuff. Then I want to, enhance the color. That's another kind of. So normally, if I want to increase the saturation, I go to the command image adjustment, hue and saturation, and I just increase the saturation. So I have richer colors. But this is not the best way, and I show you why. Sorry, open. I'm gonna get, should be a guy on the surf. Where is he? Oh, here it is. Okay, this is a surfing guy. Nothing to do with astronomy. But I want to understand if I just increase the saturation, what happens to the image? So, I can have information about the colors in Photoshop. For doing it, I use a color sampler, and I put it here on the red. Okay? You can say Photoshop use a 5 by 5 pixel average for getting information, or you go up to 100 to 100 pixels. In that case, we can use 3 by 3. It's all right. Now I can see here in the information window, I can see the color. But this is just a pure RGB information. I like to see the HSB color, which is the Newton wheel. So this is 357 degrees, so it's in nearly pure red. All right? I put another marker here in the yellow, maybe, another marker here in the blue or something, and I know that the yellow, I do the same, it's 40 degrees. It's not probably yellow, because yellow is the sum of green and red, so it's a complementary color. It lies 60 degrees from the pure red. So it should be, this number should be 60, and then I have pure yellow. But, all right, doesn't matter in any case. I want to show you another effect. Okay, now just increase our saturation, okay? It's overdone, obviously. But I want to show you that this number doesn't change. So increase in saturation, don't change the color, don't shift the hue in the color. But there is something that changes, which is the perception of the luminosity. So if we use this method, we increase the colors without shifting in colors, but we change the luminosity of the perceived luminosity of the subjects. So if you do a curve adjustment for showing something and you use that command, you change the balance of the luminosity. There is another way to do this, we can go not RGB but lab color. Lab color, it's a color space which is wider than RGB, and it's a space that our brain uses for constructing colors, because how our brain optimize how we see things. It don't uses the true value of luminosity it perceives. It just do the difference between the stimulus, between our sensor in our eyes. We have the cones and the rods. The cones are sensitive to the colors, and the rods are not sensitive to the color, just to one which is near 500 nanometers or stuff. And it uses the difference in stimulus to construct a color. It's easier, it's faster. It's just like JPEG compression. It just says this pixel is this number. On the other, I don't rescribe the three numbers or the multiple. I just describe the difference from the first. It's the same. Okay. For enhancing the color here, you can use, go to the layers. Okay. You see here we have three channels. The lightness, which is not luminance. It's different. Because luminance is something related with science. It's something related with photometry. So it's the exact value of photons that hits a given surface. That's the luminance. You can measure the luminance of an object. Lightness is the perceived luminance that we have, that our brain.
I have to get my grandson, but thank you, and I'm sorry.
Okay, I'm sorry. Maybe I'm going to concentrate. The A and B channel are the color channel, and the A channel is a color contrast that goes from the reddish purplish to greenish bluish. The B channel is yellowish to bluish. Putting all those colors together gives us the perception of all the spectra and all the color. And that's the way we perceive color in our brain, not in our eyes. So I can just increase the contrast here. Contrast, I can do it by levels. Okay. I increase the contrast, okay, in the A and the B channel. And I have much more saturated images. But what happened? The color are changed. The hue has been shifted. But the lightness is the same. So if you use this method for enhanced colors, you have the correct lightness. So you maintain the correct lightness in the image, but you shift the color. If you use the other method, you don't shift the color, but you shift the perceived luminosity of the subject. So what to do? There's a technique I developed. Okay, let's go back in lab color. Okay. And how does it work? Works enhancing the differences in the stimulus on the colors that we perceive. You go in lab mode and use the curve adjustment. Okay, you can do it by here, image adjustment, curves, and you have the possibility to change the three layers: the lightness, the A, and the B channel. So I go in the A and B channel, which are the color channel that we want to modify, and I put a dot here in the middle of the curve. Okay, it says my u in the 0, it's fixed. I don't change the u. I just increase the contrast here, 75, okay, in the A channel, and the same is true for the B channel. Those are numerical input. It's easier. You don't have to try to be precise with your mouse. You just put in here, say 0, 0. It's in the center. And you do the same. I write here the same number, 75. Okay, I did it once, but now I have to do it for the lower part of the histogram. So I do the same. And now I move this to minus 75. We make 75, right? And minus 75. Okay. Deeper color. Much more difference perceived between the hues. Yellow are much more yellow. Red are much more red. Blue are much more blue. So you increases the contrast between color also, but you didn't change the luminosity of the subject. This is a very good way to enhance color in deep sky on deep sky images, because you also widen the range of hues that you can perceive. You can have very color and full of color images, which are not easy to obtain. If I do the same here, I change it to lab, then I have pre-registered what I've done, because you can have presets. So I do the high and I do the low, just as I did before. You get colored stars. You get much more hues in the image. You can see very rich and colorful stars. Now the projector is not.
The projectors are nowhere near as good.
Yeah. If you see here, you can see a lot of stuff. And all of this, it's very easy to obtain with a fast telescope, and if you have a very correct telescope, it really gives you richer color. It's strange, but it's true. That's something we discover. I think I have to stop, because we can talk forever about all those kind of stuff. But I just want to show you in 10 minutes. This is nothing else than putting images together and give a little bit of color, and that's it. And you have the Pleiades. There are good starting point. This is just RGB, no luminance. This is the old field. Okay. In our intention, it was to take imaging during the night and showing how to process it during the day. So tonight we hope we will be able to get images, because the last nights were too windy in the place where we are. So tonight we are going to move on another place which is less windy. So and then from tomorrow we are starting to show what we get during the night, and we can put it together.
Make sure you go into the astrophotography contest.
Oh, yeah. I can show you some of the images made with the Veloce if you want. I have some. Not here, maybe in my pen.
Can you wrap up in 5 minutes or so?
Yeah.
Because then we can have another talk here soon.
There are other people scheduled to talk?
Yeah.
Oh, all right. I'm sorry about it.
At 12:30, so we have a little bit of time.
Oh,
Give
okay.
me enough time to go and eat something.
No, so I think the best thing is if you have answers, because I know it's the whole process seems to be quite complicated. But once you understand what you are doing, it's linear. It's quite linear. Okay. This is a picture taken with that small scope we were talking about, the Riccardi Honder's 200 millimeter. It's a 4.5 degree field of view, so it's quite big. That one is the Cave Nebula, and you can see many other nebulas here. Reflection nebula, dark nebula, whatever. There are a lot of stuff going on here, and you can get it just in one frame.
I can't believe that. Scope with me for 1 year, you can pick it up next year.
Let's go ahead. Try to find some other. Yeah. This one is another image taken with the Veloce. It's the same 4.5 degrees. Those are relatively short exposure. This image includes the H alpha for enhancing the contrast in red. Double cluster. It is just 5 minutes RGB. You can see how rich is the field. Yeah, that one is a pure H alpha. This one, I think it was maybe the first image we took with the Veloce. So it's plenty of stuff. You see this dust areas. Yeah, this one was the last one. It's 7023, the Iris Nebula, but the field is so huge. You see a lot of stuff going on. The VDB 141 and the Little Ghost Nebula. You see the small phantoms. Sorry. And you can see how much dust it's present in the whole area. It's another way of viewing things, wide field photography, because with nowadays CCDs, you can have also resolution, because this pixel size is getting smaller, and the number of pixels is getting higher. This is good, but you must have something to well cover those pixels. And in terms of optical design, this is a real challenge, because the standards are changing very fast. With the old film, with the chemical, the resolution was so variable and so coarse that even if you have a bad piece of optics, you didn't notice, because the spot sites that it produced all over the field are very well inside the grain of the film, so you cannot resolve the optic quality. But nowadays we simply have identical sensors all over the frame, and they are very small. If you don't have a good optics, you immediately get worse when you get off the center, or you don't have even illumination of the field. You get strange gradients. It's not that easy. And if you go down with the size of the sensor and of the pixels, the more complicated the things are for an optics to be correct all over the field. That's why we have tried to figure out some new optical design especially made for those kind of new technology CCDs, which are wide field and fast, so f3, f3.7, which in the old day means fast, but nowadays means also wide field correct. That's the point. Those are also wide field, but not with the Veloce. That what is the M13 field. If you go full size, you can see it's pretty well resolved under the core. It is 10 minutes, 10, 10, and 10. And it's plenty of galaxies. Here, 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 here. You can see many. I don't know if you are able to distinguish the galaxy on the projected image, but on the monitor I can see many, 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 many galaxies. That one is quite evident, it's quite big, but there are many, many other small ones. Incredible. This is the core. This is the Andromeda all together in one frame. And this is also, I think, 10 minutes or 20 minutes for channel. You can see dust lanes inside HEM 110. You can see dust lane going inside until the center, the very center of the galaxy. This is 1 hour exposure total, 20, 20, and 20. That's it. NGC 206 is almost resolved in stars, so pretty good result. I don't know if yeah, this one is the M42 area. This is 100 minutes exposure in H alpha plus 20 minutes for each channel in RGB and luminance. You can get this. This is one of your targets, right?
Yes.
You want to get, yeah, me too. I don't know if we're any other go fast. I want.
Voglio vedere l'M45 finita, quella.
Quale?
Dove gli hai fatto gli esempi.
Ah, sì, sì.
Prima, lavoro
Sì.
finito,
Now, yeah,
processo.
yeah. I'm going to show you the M45 we saw before. We put together more play this. Okay. This is the final result. Putting together the images you see before with much more frames. I think total is one and a half hour, 90 minutes, or stuff like that. You can clearly see bunches of dust glowing red and blue, and this is due to the technique for enhancing the color space, the color distance between the stimulus, and you can clearly, now it's much more evident on the